like, subscribe, press the bell icon for more updates. For more videos, download our app from Play Store. Faculty Diploma Program. Welcome to first session of Machine Learning and Data Science using Python.
Good morning all. I am Geeta. Welcome you all in Faculty Diploma Program of PHN Technology. You all gathered here for FDP program on topic of data science and machine learning. Before going further, I would like to introduce all our program. About us. So PHN started in 2013 as a software development company. After that, in 2018, we will join us an EduTech program. So we started here the advanced technology workshops and all the programs for the faculties and students also. Our services are business solutions, digital marketing, Android development, website development, IoT development. And from this, we are all headed to the EduTech program also. Our vision is to exceed clients' expectations by going beyond the software and training program to provide these solutions that transform a practice into the knowledge, enabling them to solve their problems. And our third mission is to provide a technology-based learning platform to all the students in India and effective software products to all the clients. For students, we are now arranging PHN Tech UA. This is the ultimate technology workshop where the students will learn from the industrial experts of Microsoft, Google, Amazon, these industries, where we are providing them cloud technology, DevOps engineering, full stack development, Android development, and 3D printing workshops. The PHN Tech UA program offers free workshops on various technologies by highly qualified industrial professionals to provide exceptional learning opportunities for students and job seekers. The key features of this program are the workshop is totally free of cost, and the industrial experts are from Amazon, Microsoft, and Google. We are providing physical certifications to all the students, and the training is on the current trends. I would like to welcome all for the faculty diploma program. So for the today's session, we have Mr. Uday Zope as our trainer for the today's session. I would like to introduce them. Mr. Uday is a seasoned data scientist with over 4 years of experience in the field of data science, including both the academic and professional career. Mr. Uday has been working on a computer vision product for the last years, which is specially designed to aid MSMEs in controlling the manufacturing process smoothly. Mr. Uday is expertise in advanced analytics and has enabled him to develop unique solutions for the worker productivity analysis. He has already created 3 successful products in the field of computer vision, which has significantly contributed to the growth of the industry. I will hand over this session to Mr. Uday Zope. Mr. Uday Zope.
Yes.
I will hand over.
Thank you, Ankita.
Yes, sir.
Okay. So, hello. Super morning to everyone. I hope everyone is doing really well. So, before starting this session, I'd like to make some consideration that I'm assuming that I think I'm audible. Am I audible?
Yeah. Yes, sir. Yes.
Yes, sir. Yes, sir.
Okay. So, before starting the session, I'm assuming that everybody is comfortable with English language. So, if there are some complexity while explaining certain concept or certain subject, so like if you are getting a difficulty while understanding certain topics, I'll be happy to share the same things in Hindi as well or any other language that you understand. So I think without wasting time, we should start the session. So I'll share my screen. So just give me a minute. Okay, is my screen visible to everyone?
Yes, sir.
Okay.
Yes, sir.
Okay, great. So I'll explain the outline of today's session first before starting the session. What we are going to do, that we will, I'm assuming that everybody is new to data science, and I'm going to introduce some of the core concepts of data science to you right now. So we can start this session with certain definitions, and we can move forward with what are the types of data science, what are the applications. We will understand the basic workflow of a data science, and then what we are going to do is that I'll ask you to do some sort of installation on your computer. So from the next session or onwards, we will start our sessions practically, and we'll try to execute everything on hands-on. Uh, so I think that will be that is a generalized overview of today's session. So I think we are good to go ahead. So I'd like to define the what is a machine learning basically. Okay. So machine learning, if you are trying to comprehend the academic definition of machine learning, it's something like machine learning is about creating algorithms and models that can learn and improve from experience, like the way humans learn from past experience. This is an academic definition. So basically, if I have to put everything in an example, so consider I do have a friend X. So he always asks for money now. So every time I'm lending him some 100 rupees, 200 rupees, 300 rupees, but he is not returning me. Now, when next time he came to me, and now he is asking me some around 1,000 rupees or 2,000 rupees, but I do have a data, or I understand because of his behavior in history or past now. Okay. So whenever he took a money from me, so he is not returning those chunks now. So what is the assumption I'm going to do right now is that this time I'm not going to lend him a money because of his past experience, because of the past experience I had with him in this particular category. So this is how machine learning works. Machine learning is somewhere you will submit a data or a history. You will have a huge amount of data, and that data you will submit to a machine or a algorithm. Algorithm basically it's a mathematical equations, and that mathematical equations or model or algorithm will try to find patterns on the data you have submitted, and it will give you an output which will beneficial or which will help you to make certain decisions. The way I came up with a decision that I'm not going to lend him a money. So basically this is a basic outline of machine learning. So now you guys must have heard about the terminologies, like this is the machine learning basically. Now you must have come across the terminologies like data science. There is one more called artificial intelligence. Now most of the people, they use these terminologies alternatively. Basically, uh, they try to use this instead of machine learning, they'll say it's a data science, machine learning, and AI is it's an all over it's an same thing. But I think that's not the case. I'll explain you what is a machine learning already explained you. Now I'll explain what is a data science actually, and I'll try to build up a relationship between these two terminologies, so you'll get a good picture of what this entire concept is. Um, so what is a data science basically? So data science is all about data. And what we are going to do, we are going to extract a meaningful insight from that for the business or particular problem statement. Now, what is a data? Data can be anything now. It can be it can be in the form of text. It can be in form of images, that we can say unstructured data. It can be you can say data generated from sensors. For example, AC sensors are there. If you must have heard about cars now, car come up with a lots of sensors. They have sensors for a diesel pump, petrol pump, diesel filters. Car have a AC sensors. So all sort of data you can use. That all sort of these things come in the category of data. Now, what is a science and tool? So science and tools is basically a mathematics or analytical skills that we incorporate with data, so we can find logics and patterns for our problem statement. Now, science and tools are something like mathematics. You use statistics, then there is probability, then there is a linear algebra, then there is a calculus, this all sort of things, and also visualization. Visualization is also plays a very important part to identify business insights or patterns in our data. So these all sort of tools we use to establish logic and patterns in our data. Now we have covered data science and machine learning definition. Now, if you observe this diagram right now, so I have created a separate section for AI, machine learning, and deep learning, and there is separate section of data science. So basically, if you want to understand that what is artificial intelligence, you can simply say that it's an human intelligence, but instead of human, it is exhibited by machine. Okay, and machine learning is a subset of AI, and data science is also subset of AI. Now, data science plays very important role incorporated with data. It helps you to build the logics and patterns. It helps you to build a curated data. Now, what is a machine learning then? Then machine learning is actually you build a logic where your data will act as an input to that logic, so you can get a results which are going to benefit your problem statement or your business. Okay, so basically this is what a relationship between machine learning and data science. So data science plays a big part in data. You can say collecting data, then cleaning a data, and then you augment the data, you do some pre-processing, you do some post-processing on data. For example, if I have to put it in analogy, so I'll do something like, for example, I do have reviews from Amazon. Okay, everybody buys product from Amazon, and if we like a product, we put a review on a website, or if we don't like a product, then we put a negative review on the website. Okay, so now every time we put a review, we use a very general language, which includes the stop words like and, when, where. These are the stops word, not, in, or grammatical words. So now algorithms and those algorithms or mathematics doesn't have to don't have to make a relationship between this sort of things. So what is the pre-processing? Then we'll try to remove those words or those uh, unimpactable entities from our data, so we can push more clean data to our model, so our model can actually learn better or more focused thing from our data. That is what a basic relationship that established between machine learning and data science. Now you must have a question that what is this deep learning below. Um, so I'm not going to put a lot of emphasis right now on deep learning, because we are going to cover that topic in a future, because that's another entity and another expertise that we have to deal with. But basically, I'll give a basic what one line introduction of deep learning basically. Uh, so deep learning is a technology, or it's an mathematical intuition where we are trying to replicate a human brain like a structure. So algorithms, so on a inputted data, we can make a more accurate and more uh, diverse decisions or results that we can obtain from this deep learning. So this is what artificial intelligence, data science, and machine learning. I don't want you guys to bore with a lot of theories that are not related. I'm trying to give you more of a crux of everything, so you'll understand everything in a intuitive manner. So we'll move ahead right now, and then so basically we have learned machine learning now. So obviously there are certain types of machine learning. So so while moving toward the types of machine learning, the first type is supervised machine learning. Now, what is supervised machine learning? So if we read this definition, that supervised learning is a type of machine learning where the algorithm is trained on a labeled dataset, meaning that the correct answers are provided. Now, what does exactly this mean? So if you observe this diagram of supervised learning in machine learning, so if you must have seen that this input, you guys are seeing that this is Apple pictures. Okay. Uh, Now, what are these annotation? Oh, annotation is the alternative terms for labeling. So we can use those alternatively. So we have to tell the machine that these are the apple. Like every time we are trying to input a data to the machine, that we have to tell the machine that these are the apples. Now, when we submit data to this particular model, what this model will do in the process of training, that it will try to build a relationship, or it will try to find a patterns through its mathematical ability, that whenever certain kind of input data comes, the annotation or the label of that particular model, the particular input is apple. Okay, this is basic. Now, what is a prediction? Now, this is a data which the input data also say or a training data which is already seen by a machine. So every if we are submitting the same data which we have submitted already in the training set, it will obviously going to give you a good results, because machine already aware about those data points. Now, you shot some pictures in your camera from some other farms, and you submit that
Number
pictures
என்ன?
to the model.
Number என்னடா?
So can you
31?
please mute your mic? Thank you. So where I'm okay. So basically, when user submit a new inputs to the model, what model will do now? Model will try to relate the new data with the pattern it has learned from the training set of data. Okay. So now when we train our model, it will identify some patterns in it. Now we are not aware about those patterns. Those are mathematical intuition. It will learn. That is what machine learning now. All the things, like if you want to learn this, how machine learns and what kind of patterns there are, we have to go more in depth in terms of mathematics now. So now it incorporate that particular input with the model, and it match that data with the patterns, and if it's giving you a probability somewhere around say 80-85%, then it will give you a label for data as an apple. This is basic outline of what is supervised learning. That basically, when we have a child, that we have to taught him a language or certain manners, so he can do those things in the future, or he can adapt those things in the future, or he can extend those qualities in the future with respect to certain things. So similar thing with the machine learning, we have to teach a model that these are the things, these are the labels for the respective thing. Now you will find a patterns into it, and we submit its new data, and it will find a result for us. So so basically, it's an algorithm will learn to recognize pattern in the data and makes prediction on new unlabeled data based on a pattern it has learned. So this is basic outline of supervised learning. Now there are subcategories in supervised learning. One is classification and one is regression. Now classification is something like, I think somebody is trying to do annotate this entire slide, Mr. Anil Kumar, I think. Can you please, I think you are trying to, I think you are disturbing the session. Please don't do this. I think I'm requesting you, sir. So, oh, sorry. Yeah. So this is what basically supervised learning is now. I was talking about classification and regression. Now classification is something.
சொல்லுங்கம்மா.
Classification is something that
2000 காசு
now
குறையுதா?
we have a reviews for a particular product on Amazon, that this particular product. Now whenever user give a reviews, we can categorize that particular review in the three types. You can say a review that user submitted, it's positive. There might be a chance it's negative because it didn't like him, and there might be a chance that it's somewhat neutral, that it was okay product. Now when new user will submit a review for a particular product, that review we can categorize into three: positive, negative, and neutral. Then what we are doing, we are actually trying to classify that particular result in these three categories. So this is basically classification. Now what is a regression then? So regression is something like we are trying to predict a mathematical or a numerical value of a certain entity. For example, so for example, you are living in a city. For example, we are taking the example of Pune. So in Pune, So in Kharadi area, the prices of an flats or apartments were somewhere around 7,000 to 8,000 square feet right now. So, and we have a data from last few years. Now what we'll do, if you are trying to search an house in Kharad area and you are not buying right now, but you're looking in the next, you are trying to get it you're doing a research because you want to buy it next year now. So you have a patterns now, you have a data which have a mentioned features like it has a information like what percentage of appreciation that peoples are getting, then how what is the trend in the rising cost of the particular land parcels. So in regression, when we sub input a certain amount of certain area, that for example I'm inputting a Karadi, now it will give me a numerical value. Okay, in 2024, the cost of land parcel per square feet will be somewhere around 9,000 to 10,000 because it understands the patterns from the history that in every 2 years there is somewhere 500 to 1,500 appreciation is happening. So this is what regression is. Now there is another type of machine learning which is unsupervised machine learning. So in supervised, what we used to do, we used to input a data, or we used to feed a data to the machine, which is label data. We used to tell the machine that this is one thing and this is output of this particular thing, or this is a truth or ground truth of for this particular result. Now in unsupervised learning, that is not the case. Unsupervised learning, you will input a data directly to the machine. Now machine or algorithm will try to analyze patterns on the data itself. Now now you must have a question, if machine does not know what is data and if he is not understanding, then how will it's going to categorize this entire data? So basically what algorithm does, they will try to generate a clusters of this data. What they will do, for example, if we take an examples of let's say dogs and cats. Okay, so if we submit a image data set, images of dogs and cats to the machine, now the algorithm will try to identify the similar features between dogs and cats. Now the similar features, for example, the four-leg animals will be categorized in the same. Now there might be a chance that cat will be categorized in the cluster of dogs now, but I think there is a lot of noise. I think. Hello, Anu. Hello.
Please mute them, sir. Please mute
I
all.
actually. Oh, okay. Okay. Please try to be try to focus on the thing because everybody is trying to learn something here. Uh, so yes, okay. So now we were talking about unsupervised learning, and I was explaining, I think, the examples of dogs and cats. So I'll show you a diagram so you'll understand in better manner. So now you can see here the pictures of cats and dogs. Now we haven't annotated this data, that we are not telling machine that this is a cat, this is a dog. Now, when you submit this data to the model, what models will do? Models will identify the features in this particular data sets. Now, what are the features of these inputs? Now, here dogs have a yellow color and some black head now. So it will understand the pattern that if certain pictures come similar to it, it has to categorize in the separate cluster. Now, you can say these two dogs is a one cluster and these four cats is a one separate cluster. So algorithm will try to categorize the input data on the basis of its features. So it will try to create it. Algorithm will generalize generalize generalized create a generalized structure of an features. So whenever new data points come, it will sort them in respective features. So that is what basically simple outline of unsupervised learning. Now, there are algorithms in supervised learning. If you have heard about linear regression, then support vector machines, and then there is the decision tree. These are the part of supervised learning. Also, artificial neural network, which is deep learning. We are going to see those in deep learning, are also part of supervised learning. Clustering, K means clustering, is a part of unsupervised learning. Then there are some algorithm incorporated with the big data. Those are part of unsupervised learning. that we are going to see. So you don't have to worry about these terminologies right now. So what is a SVM? What is linear regression? We are going to cover all those in the future with hands-on practical. You don't have to worry about that right now. So moving ahead, so what we are going to see now, we must have heard of this machine learning term is getting popular day by day now, and it's very trending. Every day there are new invention. If I told you only last year in a very specific, there is computer vision is very specific subjects in the machine learning. In last year only, there are 22,000 publications were submitted for this respect for only single topic, which is computer vision. So you can analyze or you can understand how vastly industries are adapting and how fastly progress is happening in this particular uh, segment. So we have to understand, if we are trying to learn these things, where are these things applicable? Okay. Now, medical sectors. Then there is a banking and stock market, speech recognition, image recognition. Okay. Now, what is the example of medical sector now? So in medical sectors, if you must have seen that it helps imaging. It perform medical imaging to detect abnormalities in X-rays, or you can CT scan or MRIs, or also there is something called personalized drug discovery. For example, doctor have to prescribe very specific medicines to a specific person according to his health condition. So this medical plans and everything is built by a machine learning. The doctor will feed his medical history, patient's medical history to the machine, and machine will generate some drugs patterns for that particular person. So this is what is in healthcare. In finance, or in stock market, SEBI use it for fraud detection. You must have heard about credit card fraud detection. Then we must have heard about credit scoring. Our credit scoring, the way we get a credit score, it's based on whatever transaction we do from a credit card. Then there is stock market prediction. You must have used stock indicators. Those all are the applications of machine learning. Behind them, they are using a lot of data to build up, to identify patterns, and they are trying to generate some insights from them. Now, mm, next is speech recognition. You must have used Google Assistants. There is Siri, there is Alexa. So what are these? These are the speech recognition examples or application. They have used NLP, that is natural language processing, which is one of the technique in machine learning, to identify instruction given by users to the machine, and machine will interpret those instruction, and they will perform certain activity, and will generate a result. Then what is image recognition? As I already explained you that in medical sector, image recognition is using. Also, you must have heard about traffic analysis, and also one of the very great example of this image recognition is on the toll gates, where if crime branches, or you can say face detection system, where you will be your attendance will be marked based on your face. System will identify your face, what label you have. So these are the applications of the machine learning. Other applications will be in transportation. uh, so transportation is like, you must have heard about self-driving cars, then traffic prediction, then route optimization. Whenever you ask the route for a Google map, so it will give you a route which will take a minimum time to reach your destination. That is also one of the most popular applications of machine learning. Then in natural language processing, then there is sentiment analysis, there is language translation. Google has also a language translation system where you will give you an input from certain language, and it will give you an output from the expected language that you want. Then there is a manufacturing, in robots controlling, predictive maintenance, for example. Hello, is there any problem?
200 मेंबर 200 मेंबर हैं यार 200 मेंबर हो गए ज्वाइन करने वाले ये सब बहुत होते
Hello. Yeah. I was explaining the application now. In manufacturing sector, there is a predictive maintenance, quality control, and the supply chain management. We use a machine learning. Then there is a agriculture from drone. We used to um, we will observe our crop yield prediction, then soil analysis, then there is pest control. These all are the applications of machine learning, and day by day things are getting more popular, and people are trying to incorporate machine learning with the real world application. Now, if I have to give an
Excuse me.
example that where you guys have came across this machine learning application, I think YouTube is a very good example where you watch certain kind of video. When you open YouTube next time, you'll get a very similar kind of very similar kind of recommendation from YouTube. So behind all this recommendation engine, YouTube is collecting cache data from your browsers, and it will running a machine learning model that is particular respective users are very much interested in certain topics. So it will next time when you open or when you visit that particular website or particular uh, application, then it will recommend you that it will recommend you content from that very specific zone. So this is also one of the applications of machine learning. uh, so now we have done applications, we have
Excuse me, sir.
understand.
Yes, sir. Sir,
Hello.
I have a doubt. Can I ask now?
We will be having a session of our Q&A at last.
Okay, okay, okay.
So
Sure.
we'll do that. Okay, thank
Actually,
you.
one query was there regarding the slide. You have written some NLP. So NLP means non-linear programming.
No, it's not non-linear programming. Sorry, I forgot to mention. It's a natural language processing. It's one of the
Oh,
key
okay.
concept in machine learning.
Okay, sir.
So which we are going to cover in the future. So don't worry. So if you are not going handy with some of the terms that I have mentioned in the slide, so you don't have to worry about those things. We are going to visit each and every single things in the future sessions. So you don't have to worry about things that if you are not able to comprehend right now completely. So don't worry. So
Thank
now,
you.
Sir,
okay,
please explain application in classification.
okay, application.
In
So
classification.
okay, we'll do one thing now. What are questions you have right now? Because everybody will go behind in the session now. So whenever we organize a Q&A session, we'll explain each and every query from your side. Okay, is that good?
Sir. Yes, sir.
Okay, thank you for understanding. So right now, what I'll do that we have explained everything and we have understand the application. So we'll try to understand basic machine learning workflow now. So how a machine learning problem when for example certain industry gives you a problem statement, then how you are going to approach, then what are the cycles, what are the steps involved in that particular problem for solving that problem. uh, there might be a words like evaluation, features, and modeling you might not be handy or you might not be aware about right now, but I'm promising you that you'll able to understand or you'll able to grasp all those concepts in the future, technically as well. So we'll start this outline. So first step uh, in machine learning or for solving a particular problem statement is the data collection. No, as you must have heard this phrase that data is a new fuel of a 20th century. So everything in the machine learning is based on the data. What kind of data you have? What is the quality of that data? Okay. So now you have collected a data. Now collecting a data is a separate entity. When you are trying to collect a data, there are number of procedures or number of methods that you use to collect the data. For example, you do a web scraping, then there are certain amount of certain data sets that are already available. There might be a data which will be generating from the sensors that you have. So any kind of data. Okay. Now next phase is data modeling. Now data modeling has these certain phases, 6 phases now. So I will try to dig those six phases now. Now what is a problem statement now? So basically a problem statement. So sorry, just give me a minute. Sorry. So what is a problem statement? So problem statement or problem definition, when we say problem definition, then it's an what is a it's like uh it's a statement that what you are trying to solve now. Okay. When some clients come to you and he'll mention his problem now. That is what a problem statement. And how can that particular problem you can phrase as a machine learning problem? That is what a problem definition right now. So now when a certain clients or certain person come to you for a problem definition, then you must have to categorize that problem definition. You must have to do certain analysis. Okay, this problem statement might be fit in supervised learning. This might be fit, or we have to go for an unsupervised solution for this particular problem, or we can go directly to deep learning, or we can do a reinforcement learning. This all sort of categorization that we have to do. So, for example, if we have to, um, so, so also after classifying, sorry, after deciding whether that particular problem is supervised or unsupervised, then there is a next step whether the problem is a classification problem, or whether it's a recommendation problem, or whether it's a regression problem. Now, this all sort of things you are going to learn, and you will be learn how we are going to do all sort of analysis on these problem statements throughout this all the sessions. Now, let's take an example of an insurance company. So where you I think you receive thousands of claims per day now, which your staff read and decide whether or not the person sending claim is I think false or not fault, or not. So but number of claims you are getting right now, it's more than the staffs you have right now. So you got thousands of examples for the past claims which are labeled at fault or not fault. So now, can you say that machine learning is going to help us to solve this problem? Because you have a 2-3 employees and you have thousands of requests every day. So what you are going to do now? So you are going to do analysis, and you have to sort this problem into the phrases like classification, recommendation, or regression. Now let's try to phrase this particular problem of insurance company into the terminologies of machine learning. So what we can say that we are a car insurance company, and what we want to classify incoming car insurance claims into fault or not at fault. Now, if you heard this statement correctly, what we say, we want to classify incoming car insurance. So you can say that this problem is falls into the category of classification. Okay. Potentially, there might be a chances that certain request coming from a user or coming from the insurance company might not work, but your first intuition for this particular problem is a classification now. So you started development now. You understand the problem that you have to classify whether the claims that are coming are at fault or not at fault. So that is the first step we have done. Then next is data. Okay. So now what kind of data we have? We have to understand these things basically, because there are the solutions in the machine learning which are based on the what kind of data you have. For example, if you have unstructured data, something like images, videos, then definitely those falls into the category of computer vision, and those are the solution which works very well on the unstructured data. If it's a structured data, you can say a Excel sheet of an transaction, customer transaction, or a database of a patient's record. And the columns can be numerical, columns can be in the form of text, or patient's average heart data, categorical data, their sex, then there is chest pain intensity. So or any kind of field that is incorporated, that is related to your problem statement, can be a structured data if it's in the form of row and columns. So that is a structured data. Then there is a static data. Static data is something like some static data is you can say the customer purchase history of a certain organization. So that is a static that is not never going to change. That will be a static data. Then streaming data. For example, your sensors are generating constant data flow to generate records. Now that is a streaming data. So this all sort of data you have to understand. And also
Now,
photos while the program is on live streaming and it will be provided to you later. Kindly maintain silence.
hello, just a minute. Anu, Ankita.
Kindly locate your seats. Just by inquiring.
Yes, sir. I will unmute her.
Try to mute everyone. I think people are getting distracted with this.
Yes, sir. Continue.
Okay, thank you, Ankita. So we were talking about the data. Now, for so similarly, you have to understand that if it's a now we have already understood that our problem is a classification problem. Now we must have a data and its respective labels right now. For example, this particular insurance which is come at your customer, sorry, or at system ends, need to have a certain labels like it's a fault or not fault, which fault will describe as a yes, or a not fault will describe as no. So if it's a fault, yes, so yes or no. So whenever you are trying to classify the entire problem into two categories, usually there is a term in the machine learning, we call it as a binary classification. If there are more than two classification, then we say it's a multi-class classification problem. So that is a term we are going to visit in coming sessions. So now we are done with the data. We understand our data is a structured data. Now, what we have to do is that what will be a definition of a success for our problem. Okay. Now, how you are going to measure that what your data you acquired and what your algorithm that you are going to relate with this data, it's whatever results you are going to obtain are now how we will mark that obtained results are successful or not successful. So we do have certain metrics in machine learning. Again, we are going to visit those metrics in the future. Let's put everything in an example again, so you'll get a better clarity of those examples. So again, there are different evaluation metrics for a classification, regression, and recommendation system. So for our project, which is a insurance claim project, if you say the model needs to over a 95% accurate at whether someone it has fault or not fault, then we can say our model is performing pretty good by predicting who is at fault on the insurance claim. So that is what we say. Now, this respective accuracy is well and very good for this respective problem statement. But if you try to come up with a problem statement which is related to the medical profession, you cannot say these things. That the particular guy, like there is a 80% chance that you are not going to survive in next 6 months. You cannot make certain kind of statement. So you need to have somewhere around 99.8% kind of accuracy for those kind of problems. So that is another. So it's also problem specific. So whatever matrices we are going to decide for a problem statement, which are also going to be based on the kind of problem we are solving. So basically there are concepts like true negatives and recalls are there, F1 scores are there. Again, no need to worry, we are going to visit all these things. Then there is a confusion matrix is there. Then there is a mean absolute error, root mean square error. All these concepts we are going to visit while we will be doing this session, or we'll be doing hands-on things. So right now we are only trying to understand the basic outline of how an entire problem statement go through, or what are the stages of those statements. Now, what are the features of the problems? What are the features of the your data? So your data, if those data in the form of rows and columns, your rows, every single column is going to define some unique value, which are going to make some impact on your expected results. That is what. So every features you can say loosely that every column is a feature for you. Now, if you are, for example, if you are trying to categorize something, some products, for example, in Amazon, if you consider Amazon data sets and there are utensils, then you'll categorize them in the kitchen utensils, or there are curtains, then you can categorize it as a furniture. So there are certain there are features which we call as a categorical features. For example, uh, in a heart disease problem, the sex of patients, or or in online store, whether someone has not made purchase or not made purchase. These are the categorical features. Okay, then there are continuous or numerical features such as heart rate of a patient, or if you are trying to uh, analyze a number of times, how many times a person log in into the system, that can be another continuous features, because values will be always in the form of numeric data. That's why it's a numerical feature or a continuous features. Then there are derived feature. So when there is a concept in machine learning. Sometimes what happens, a single column is not making too much impact on our output result. So we have a technique. When we'll try to find a correlation between columns, and we'll try to come up with a new features. We'll try to combine those two columns, and we'll try to make a new feature. Now that this new features is going to make certain amount of impact compared to when two of the features were a separate entity. So those features we call as a derived feature. So I think sorry. So these are the features in the machine learning. Now, what is a modeling? Now, so modeling is basically, you can say, algorithm. Okay, algorithm or steps or a mathematical equations that you solve, that are going to solve your problem that you are trying to solve. So we do check, we do train model, we submit data. Now we have a data, we have done with our metrics, then we have done with our features, we did feature engineering, we did problem definition, everything we have understood now. Now what we are going to do, we are going to train our model on our data. So now so it's not necessary that when you train this model on this particular data or particular streamline that you have come through, entire process that you have come through is going to give a greater result. You have to do a continuously experiments to choose a model. Now, how you are going to track an experiments of model? It's a very basic thing that you will train a model, then you will give an input data. Then on the very same input data, if model is giving the expected results, then you will store that model in certain directory. Then what you'll do, you'll do some changes. Now these changes have a very specific term. We call it a hyperparameter tuning. So we change certain values in our algorithm, which are going to make a certain impact on outcome of our algorithm or outcome of our system. So there might be a chances that performance of an algorithm might go up or it might go low. So that's again an experiment. So now we have to do, or we have to go through certain experiments again and again and again till the time we get a model that is very accurate according to our expectations or what we are expecting from our model to perform. So that is what choosing a model now. Okay, now you have done with model. Now what is the evaluation? Now evaluation is, or experimentation, sorry. Experimentation is what you have done everything. Now you have compared model. You have compared model on a data. Then you got a entire results. You did some visualization that this model X is performing better than model Y. Now you have to do experimentation. Experimentation is what now? So what you will do? So now till the time you were performing all the experiments on a very limited data. Now what you will do in experimentation? You will launch or you will deploy your model in a beta mode, where your model will be handling a request from an unknown entity. Definitely, the request or input should be in the form of the way algorithm has to understand, or the input data also need to have features that algorithm has been trained on. So that is a very basic, that is a fundamental requirement we need to look after in certain machine learning problem. So now in experimentation, so now we have trained it. Now we have to validate the output in experimentation, that how our data is performing on an unseen data. Now unseen data in the sense the data which we haven't used while training an algorithm. Now, so that is experimentation. We do have a data sets, like we have a training sets, we have a validation sets, we have a test data sets. So this all sort of things comes under the experimentations. Now, unless and until we got a good result in an experimentation, we cannot move further steps. That is the deployment. Now, in deployment, what you do actually, you put everything. Now you have built the entire system, you got a results, you are matching a client expectations. Now you want to put this particular system on certain cloud or certain system, so it can perform its duty, or it can serve its purpose in the real world. So this is what entire or loose concepts of entire machine learning uh, workflow. Definitely, we are going to build some projects, or we are going to build a projects where we are going to go through this entire system. We'll be building this entire pipeline, and so you will get a hands-on experience on how actually practically how we are going to implement each and everything using very simple techniques. And I'll try to give you maximum explanation of codes as well as of concepts at the time of writing a code. So that is basically and machine learning workflow. Yeah. So this is the basic outline and then okay. Now this is a very basic introduction that we have gone through now. Now what are the tools that we are going to use throughout the sessions now? Now we are done with theory now. Okay. So tools. Now this is NumPy. It's an library in Python where everything is vectorized to get an good computational to get an good resource good use of resources. Then there is a pandas, matplotlib. These all other tools. scikit-learn is one of the most popular libraries for a classical machine learning, where all the algorithms implementation is already there. We have to use and we have to inherit, or we have to extend the classes defined in a scikit-learn to implement the machine learning system. And then there is an IDE or a Jupyter notebook. We say it will be a platform, or it's going to be a go-to IDE for us to perform all the experiments. So where we are going to write all the code, all the codes and all the comments, and whatever topics I'm going to explain you throughout these sessions, we are going to write all the notes in itself in the Jupyter notebook. Whatever notebook I have created, I'm going to share those notebooks on a certain links. I'll ask my I'll ask the team to arrange a certain platform where we can share these things with you as well. We are going to do an installation of Anaconda. Anaconda is another platform where all the tools have been all the tools have they have kept all the tools on a very same place. Then we are going to use Python 3.8 specifically for this sessions. And then Seaborn is another visualization library. So we do and if so if when we will build a project, I'll try to come up with a VS Code, so you'll get an idea how we create a folder structure and everything, or how basically I'll give an outline of how entire uh, industry standard project should be, or how actually industry try to build a software around certain data and problem data. So that is most possibly I'll try to cover as well. And then what I have right now, I'm assuming that everybody is having a laptop or certain system with them. Is that true? I think. Uh, so what we can do, basically this introduction we have completed an introduction right now. Now setting up an environment. So so I don't have an idea that how much you have understood whatever I explained, and then there are certain prerequisites for the machine learning. So before starting a machine learning session, you have to understand, you have to know basically Python, then certain libraries stand up NumPy and Pandas, Matplotlib, scikit-learn. You need to have a hands-on experience on it. So for executing and for implementation of everything, I'm going to ask you to do a setting up an environment. So from the next time, there will be a no slideshow. So we are going to write a code live. So I'm going to write code in front of you. So you will get a hands-on experience, and you will able to you will able to get confidence on yourself that you will this is not a very rocket science things. It is very easy and you can do it. So that is what my approach. And so we are not going to very deeply in the mathematical intuitions. If there are necessity for a certain topics that I have to explain explicitly a math behind it, I'll try to come up with a very simple solutions or simple explanation regarding that particular subject. At that time, I'll explain it on this spot. But I think what way we are choosing right now, you must have understood that we will be performing only hands-on practical things and throughout all the sessions, where while learning and while executing, I'll explain you all the codes line by line, why and how these things are happening. So that is all. So if most of you have a system and everything, what you can do, you can download the application called Anaconda. So
Excuse me, sir.
uh
Can we do it in Colab, sir?
yes, definitely you can do it on Colab.
Okay.
Definitely, yeah. You
Okay.
just have to, okay. Even if
Hmm.
if some people do not have some good system or latest system, they can use Google Colab as well. Google Colab is a similar kind of platform like Jupyter Notebook. So I'll do one thing. I'll showcase everyone how to log in into Google Colab, so everybody will get an idea. And if some of you want to install or some of you want to do a setup on your own system, you can do that as well. So I'll also demonstrate that. So basically, I'll do one thing. I'll do a Google Colab thing. Okay. Okay. I think everyone can able to see this screen. You have to search Google Colab in your Google browser in your web browser, and there is a first link you'll get. Welcome to Colab. You need to sign up in this particular account from your personal account. So you'll get a certain this kind of UI on your screen. This is a one way that you can execute your you can follow me throughout the sessions. And there is another way that I'd like to showcase if somebody wants to install things on their personal or local laptop or local computer. So this is a link I'm going to put into a chat now. Also, if somebody have a Mac or a Linux system, I'm going to put a video link of how to do an entire setup on a Mac and Linux system as well. So this is a link where you have to install. Just a minute. Okay, chat. Okay, I have put a link in a general chat so everyone can see it. You can go to that link and download Anaconda. It's somewhere around 600 MB. And yes, is everybody is have you ever used Anaconda or any kind of IDE before? Okay. Most of you definitely whatever ID you are. I think in PyCharm, the problem with PyCharm, you cannot use the Jupyter notebook in PyCharm community version. That is the problem with PyCharm. So I'll suggest you, instead of PyCharm, go for VS Code. So in paid, you have to buy a JetBrains subscription to execute Jupyter notebook on PyCharm. So that is one problem with PyCharm. I think I'll suggest you to go Google Colab, or you can use a Jupyter notebook. So I'll showcase how Jupyter notebook will look on the system. I'm assuming that everybody will install. I'm going to share a video link into the description or in this chat. Okay, most of you are saying you are comfortable with Colab, and so I'll show you for the people who are going to use Jupyter notebook. I'm going to show you how things will look in Jupyter notebook. Give me a minute now. Okay. I'm assuming that you will be installed and you have installed. You just have to download that software and you have to double click. You don't have to do anything. You don't have to do anything except all the agreements and everything, and just finish the installation. And then after finishing an installation, what are the steps you require to do? That we are going to follow right now. In Google Colab, you don't have to do anything. People who are going to follow Google Colab, please wait for a few minutes so we can move forward in the session. So I'll do one thing. I'm sharing. Okay, I think everybody is able to see my screen right now. Is my screen is visible to everyone? Okay. So what, after installing an Google Colab, after installing an Anaconda software, what you have to do? You have to search in your start menu, Anaconda. You'll see Anaconda prompt here. Okay, you have to click on Anaconda prompt. Now you will see a certain UI where there is a base keyword will be there, and your C drive users and your usernames from which you are logged in the system. Now we are going to start only Jupyter. We are going to use a Jupyter notebook throughout this sessions. So you don't have to worry about any other tools, or you are going to use, or people who are going to use a Colab, everything will be the same. So you just have to type Jupyter notebook here, or I'll suggest you guys that you should create a new folder for this particular session, so you can maintain the records of all the sessions throughout, and you will able to recap everything while attending the next session. So what we'll do, we'll create a directory. Okay, we'll move into that directory, day 1 for data science. And what you have to do, you have to type Jupyter notebook with space between it. Okay, everything in small caps, and press enter on it. Okay, you will see this kind of again interface in front of you. Okay, I hope everybody is following me. So I think if some of you haven't installed this Anaconda software yet, then you might want to visit Google Colab as well. So what you have to do, people who are following Jupyter Notebook on me, what you have to create on new, on top right corner, there is a button called new, where you will be having a Python 3 RPY kernel. Click on it. It will create a new notebook for you. Give a title to it. Fundamentals of Machine Learning. Okay. Now, people who are using Jupyter Notebook need to do certain installation. Yes.
Good morning, sir.
Good morning. Good morning.
Sir, I have one doubt, sir. How to install Anaconda in 32-bit operating system, sir?
32-bit operating system.
Yes, sir.
Okay, just give me a minute. Okay.
Sir?
Give me a minute. I'll
Okay, sir.
can I know a specification of your computer?
Sir,
Can I know a specification of your computer? So what
this
is the
is
RAM and
1 second, sir.
yeah. So because Anaconda is considerably very resource oriented platform, it will eat lot of resources. So it's better you should shift on Google Colab if you don't have that powerful system.
Okay, sir. Because it is showing this is not supported like that. That's why.
Okay, don't worry. You can shift to
This is
Google Colab.
x86 based PC, sir. Intel Core i5.
Okay, it's i5 processor. Then I'm sharing one link now,
Okay,
in
sir.
so you can download from there.
Okay, sir. It is not supporting for 64-bit operating
Yes.
system. This is 32-bit operating system.
Okay. 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 I think I forwarded link into the chat, general chat.
Thank you, sir.
Sure.
Sir, I have a query, sir. Can I
Yes,
ask you?
Yes. Sir.
Basically, my query is to the organizer. Can I get the recording or the presentation of your, the slides of your presentation or the recording?
Just a minute. Ankita, can you clarify this?
Yes, sir. We will share this.
Okay. Thank you.
Okay, thanks. Thanks.
Okay, thank you. Also, you guys don't have to worry about the content. So I'll do one thing. What I'll do, whatever session, whatever content I'm going to create throughout this session, I'm going to share. I'm going to, I'll do some Git repository from where you guys can able to access all the content. That will be very handy for you, and it will help you to remember everything, and you can practice as well from that in future. Okay. And so I think the ma'am who asked me about 32-bit system, I have shared a link into the general chat, so you can download from there. And okay, so now people who are using Jupyter Notebook might not have installed NumPy, Pandas, and Matplotlib or scikit-learn, the libraries which we are going to use throughout the sessions. So what you have to do right now? So you have to remember these commands now that I'm going to type here, which is pip. Pip is a tool which we use to install Python libraries. Install and whatever libraries you want to install, which is I'm going to install NumPy. It might give me an error because it's already installed on my system. It will take some time. It will download that particular software from the internet. Yes. You require been already satisfied. It's already installed. Then there is another command if you want to install pandas, then pip install pandas. This is another library where we are going to which we are going to use extensively in exploratory data analysis. Which
Sir,
is a
your
process.
screen is not visible, sir.
Oh, sorry. Okay, sorry. Okay, now it's visible, I think. Now it's visible?
Yes, sir. Yes, sir. It's visible.
Okay. So the first command is, we'll do one thing. We'll create a markdown as well here. We do have option. Okay. Okay, now I'll give you a basic outline of this entire. I hope everybody actually you can do installation later as well. You don't have to follow right now. Because you are going to get this recording as well. So what I'm trying to do is now I'm going to showcase you how this how interactive and how well this entire Jupyter notebook is, and its features and functionality, what needed to us throughout these sessions. So so these are the basic commands you need to do. So this installation: pip install numpy, that is the first command. Then pip install pandas, that is the second command. If you execute, you have a run button here, or alternatively you can use control plus enter if you want to execute certain cells, that is control plus enter. Okay, there is a one more option for executing. If you want to create if you want to execute this single cell, and at the same time you want a new cell to get created, what you can do, you can do alt plus enter. Okay, so every time you press alt plus enter, you will get a new cell will be get created. Okay, so these are two libraries. Another library you need to install is pip install matplotlib. This is a visualization library which we are going to use for plotting a data such as histograms, then scatter plots. Then we'll be doing a univariate analysis on data. So that time this library will be handy. So that is one thing, pip install matplotlib. So remember guys, Jupyter notebook people who are using Colab, they don't have to do these things because Colab already have this environment set it, and you can simply use this library by that I'm going to show you how you can use it. First we'll do installation. Then there is another library called pip install scikit-learn. I think I spelled okay, sorry. This is the most popular machine learning libraries. Again, it's installed. Now also we will cover that in Q&A. Then there is Seaborn, which I have mentioned. Pip install Seaborn, which is also a visualization library, works top of the matplotlib. It uses matplotlib as its a foundation, and it helps us to create a very interactive visualization. Everybody is following me? So also there is one more question from my side, that how experienced you guys are in Python, so I can cover the topics. Not the beginner, people are saying beginner. So okay, what you can do. So even before starting NumPy and Pandas, I'm going to cover basics of Python. What is a Python actually? How simple it is, and we'll cover basic arithmetic operation. Then we'll discuss our data structures, and then we'll move forward to a loops and conditional statement. And one more important concept that we have to learn in with respect to machine learning from Python is file handling. That is very important for us. So we'll cover these topics before starting actual machine learning sessions. So that will everybody should be comfortable with the code that we are going to write. So most of you are saying beginner. So we'll do one thing. So I'll share you an outline of next session as well. So once if I get a confirmation that everybody is following and everybody has done these things, so I'll move again in our presentation now. These are very basic command. Even we can do this setup. We can execute this command at the time of execution as well. because whatever time we have to spend on the installation, we are going to do that right now, because we don't want to waste time in setting up an environment. Every time you guys might face some kind of error. So if I try to solve all the errors that you guys are facing, then other people, it will not be very productive for other people. So try to understand, please do a setup very clearly, so everything will be followed very smoothly throughout the session. So I think I'm considering everyone is almost done with the setup thing. So now I'm going to share this. I'm going to stop this screen and we are again moving on the presentation. Okay. So now everybody is a presentation. So these commands are already installed, so mentioned in the. Don't worry about Conda Activate. If you are directly starting it from the Anaconda Pro, you don't have to put this command Conda Activate. So now, so these are the basic requirements of a machine learning that everybody should be familiar with. So from the mathematical point of view, you should able to understand somewhat up to some extent linear algebra. For example, if you are handy with the equation, we say mx plus b, which is the equation of line y is equal to mx plus b. Now that kind of things you have to understand if you really want to understand the crux of how algorithms are actually working. Then basic terminologies of statistics, mean, median, then somewhat central limit theorem as well. I'll try to explain you. Then there is a distributions. You need to have familiar with the Bell curves and normal distribution. Then there is somewhat probability. Then matrix multiplication is one of the most important concepts that we use, and one of the most used concept in the machine learning. Matrix multiplication. I'm saying dot product of two matrix. Okay, not a simple element to element matrix multiplication. Then I think you also have to understand what is a vector, what is a scalar. So eventually, I'm going to explain those things while performing practical. And then in terms of programming, you need to understand or you need to have an idea. Can I have your email address? Okay, we'll go into that section. We'll discuss everything in a Q&A. Fundamentals of concepts of programming, which is in Python. If you know, like, there is not a problem if you understand these concepts of programming in some other language like C, Java, or anything. But machine learning is very close to Python, or most of the libraries developed for the machine learning are for the Python only. So we are preparing Python, and Python is used vastly in the industries right now. Whatever products I have built throughout my career, I have used Python exclusively, so you don't have to worry about that. Then there is a data structures of Python, which is list, dictionary, and tuples, and sets as well. I forgot to mention. So this data structure you need to understand how they work. We are going to get a very basic idea of these things in the next session. Then you have to understand loops, how loops are working in a Python, what are the syntax, then conditional statement, if else, there is no switch statement kind of things in Python. Then file handling, how to open file, how to read file, how to store file, how to create directory. Then Python function, how to define the functions in the Python, user defined functions, how to return a value. And there is no such thing of a data type. You don't have to mention a data types in Python, for example. So these are some of the advantages are there in Python. So these are the things I'm expecting that should be prerequisite. So mathematical, I'm going to explain whenever the concept encountered in our explanation, then I'll go. But programming, we are going to cover the programming in our next session. So next session we'll do fundamentals of Python, then pandas, then NumPy, then we'll learn some of the plotting, matplotlib, and next session at max, what we are going to do, we'll use one data set, maybe housing prediction, or maybe iris data set, which is these two data sets are go-to data sets if you are trying to learn, if you are beginner in the machine learning. And we'll try to do a exploratory data analysis on that data set. So also this term is not familiar with you guys, so I'll explain this term on the very same day, so you don't have to put a lot of pressure right now. You don't have to remove this thing on those session. So these are the things that we are going to cover in the next session. So now, Ankita, I think that is what from my side. Now, if you have anything to share, you can.
Yes, sir. I wanted to take a moment to express my gratitude for attending our recent Zoom meeting. Many thanks to our trainer, Mr. Uday Zopi, sir, for this wonderful session. Your presence and active participation were truly appreciated, and your insights and contributions added great value to the discussion.
For more videos, download our app from Play Store.